Hey everybody, it's Jeremy from the Renegade Coder, and if you remember from earlier this week, I posted a video about list comprehensions in Python. Well, now I want to bounce off that video because at the end I talked about how to duplicate lists using list comprehensions, and now I want to do an entire video about just how to duplicate lists. So that's the topic for today, but before we get there, I just wanted to point out that at the end of this video, I will be doing a challenge. It's something new I want to try. And it'll be related to how you duplicate lists. So if you're interested in that challenge, stick around to the end, and I'll ask for you to share that in the comments. First thing I want to talk about is what our list will actually look like. And to save you some time, I've actually gone ahead and created a list. And if you take a peek, it is going to be a list of all the top Penguins players. I picked the top 3, Crosby, Malkin, and Letang, but you could populate this list with whatever you wanted. But since I'm wearing a Pen shirt today, I figured might as well stick with the theme. Now that we have our list, what we want to be able to do is create a copy of it. So it should be Pen's copy, and then it's going to look exactly like the original list. So I'm actually going to edit the name of the original list. We should be able to do something like Pen's is Pen's copy, and that should return false, meaning that they are not the same list. In other words, we have 2 different lists with completely different references in them. In no way are the items the same, and in no way are the lists themselves the same. What that means is we're not able to do something like change what's inside this list. So let's say in Pen 0, I decide I want to change this to Matt Murray. Well, Pens will change, but Pen's copy should not change. And you can see that here. Now, I should probably mention that there's a pretty big assumption we're making in this video, and it's that we're not going to be dealing with objects in our list. We're only going to be dealing with immutable types or primitives. So in this case, we're dealing with strings, which are objects, but they're immutable. So there's no way that I could, for instance, say change the Sidney Crosby string so that it would affect the Sidney Crosby string in the other list. With all that said, I think it's safe to go ahead and get started. If you think about it, all we really have to do is create an empty copy list, and then we can iterate over our primary list and add those items into the secondary list. So in this case, we'll go ahead and say for each pen in pens, and then we'll just copy that into the pens copy list. So we'll use append, and we'll pass the pen in there. And now pens copy contains all the same items as Pens. But in this case, we'll be able to do something like check is Pens copy, just to confirm, and of course they're not. So this will be your first solution. This is a sort of a brute force solution, meaning we're going to be able to loop over each item in Pens and store that item in Pens copy, and that's it. Now, the brute force solution is great and all, but I wouldn't be doing myself any justice if I didn't create a list comprehension for you to look at. So again, I'll go ahead and write this list comprehension as I usually would. So I'll say item for item in pens, and that should create a copy. And if you remember the brute force solution, this is almost exactly the same. It's just condensed down to one line. So what we're saying is for each item in pens, store that item in our list. And that's it. I just like the solution because, as I said in the other video, list comprehensions are fun for me. They're just fun to put together. They're clever. I don't know if they're considered great syntax, but I just have a lot of fun putting them together. And in this case, this one's pretty simple. It's just for each item in the pens, store that item. You can see how this is pretty much exactly the same as the brute force solution. We've just condensed it down to one line and removed some code like appends and extra lists and whatnot. So at this point, we'll sort of just move past the brute force solution, as there are plenty of other more elegant solutions. The first one I want to start off with is actually a slice, which looks like this. And if you're looking at this, this looks pretty strange because you have this list notation with just a colon in the middle of it. But what you'll find out is that Pens copy actually is exactly what we're expecting because we've just used a slice to replicate the original list. And if you're curious what a slice does, what you could imagine here is something that looks like this. And with this syntax, what we're saying is start from the first element and continue until the end of the list. So you can actually extend this, so 1 to 2 would actually just give us the element between 1 and 2, which would just be 1. You could go 1 and 3, which will give you the second and third elements. And we can actually take this slice and use 2 colons. So what you can imagine is the first item would be your starting index, which we just showed, so 1. The second item would be your ending syntax, so maybe it's 3. Or we could go 0 to 3, which will give you the entire list. And then we can use a step here, which will tell you how many items to jump. So 2 is actually going to skip over the middle item. And then at this point, we can do something even more clever now that we know that step exists, and we can duplicate this list backwards. So I'm just going to use this empty colon, and this should recreate the list in reverse. So now you start with Crystal Tang and end with Sidney Crosby. So that's sort of the slice syntax. So you can imagine if I leave this blank, we get a full copy of the original list. It just goes end to end. But you can add numbers to sort of filter or separate, however you want to use the slice syntax, but that will create a copy. Now, if you thought that was elegant, there's actually an even more clever answer, which takes advantage of the copy constructor for lists. So if I pass pens directly into the list constructor, we'll get a copy. And as you'll see, we have duplicated the list. Now, I don't have much to say about this other than that this is a nice feature that is provided to you by list. All you have to do is pass in one list into the list constructor, and the list constructor is going to duplicate it. So in this case, pens copy is not pens, and we'll check that as usual. And that's proof enough. If you felt like things couldn't get any simpler, it turns out that lists actually have the copy function built in. So if I go ahead and set up my copy, I'll go ahead and say pens.copy straight up. And actually, you can read the description here. It just returns a shallow copy of the list, which I think I mentioned sort of briefly. What that means is it's not going to actually copy the elements inside the list. It's just going to create a new list and populate that with the items from the other list. So this is safe to use with immutables or primitives, so it's safe in this case. But if you have objects like maybe dictionaries or other lists, this wouldn't be a safe solution. So now you use pens copy, and you'll see we have a copy. And just to prove to you that we have a shallow copy, what I can show you is pens at 0 is pens copy at 0. Whoops. And what that'll do is show you that the Sidney Crosby string in pens and the Sidney Crosby string in pens copy are the exact same string. Same reference and everything. But of course, since strings are immutable, there's no way that you can change the one string and have it affect the other one. So this is perfectly safe use of the copy function. Now, if you weren't a fan of the built-in copy function for lists, you might want to leverage the copy library. Basically, the copy library is just a generic copy library, and it will provide copy functionality for any object that you want to pass to it. And there are 2 copy functions that are provided by this library, which are straight up copy, so I'll show you that. Copy.copy, and then you pass what you want to it. So if you wanted to read the description, this performs a shallow copy of arbitrary objects. So I'll go ahead and pass the entire pens to it. And then you'll see that we've created pens copy. And we can prove that those are 2 different lists again. If we do pens copy. And so that's false, but we can always prove that it's a shallow copy by passing 0 to it. So pens copy, and that's true. But copy also includes a deep copy, which is something we haven't talked about yet, but we'll go ahead and do here. So we'll go ahead and create an object called pens deep copy, and we'll do copy.deepCopy, and we will pass pens to this. And so it says deep copy operation of arbitrary Python objects. So we'll go ahead and create that deep copy. And you'll see here, it looks exactly like the regular copy. I only really have one more solution for you, and it's not a solution I recommend using. In fact, it's a bit odd, but I just wanted to show it because it's kind of funny. What you can do is you can multiply your array. So if you've ever done this, let's say I multiply this list by 5. It's going to duplicate the list 5 times. But if I multiply it by 1, it just duplicates the list. So we'll go ahead and take pens copy and store a result of this. And we can actually verify that Penn's copy is not Penn's. And we've done that by simple multiplication. Now you can probably imagine why you wouldn't want to use the solution. One, because it's sort of unreadable, and two, because it's kind of unreliable. Again, it's only going to perform a shallow copy. And I mean, who's going to know that that's what you're trying to do here? You're going to probably have to like leave a comment that says, oh, performing a copy, because this just isn't standard. Of course, we'll take a look at performance later, and maybe this is really fast, so you might save some time, but I haven't confirmed that yet, and we'll do that in the next section. So at this point, I'm just going to start doing performance testing. I haven't done this for the article yet, so it might take me a minute. I'll edit this down so you're not watching me just kind of sort of copy and paste pieces of code, but we'll go ahead and build this setup string, and then we'll want to go ahead and build up all the rest of our strings. So, and actually I think I want to change my setup string to include copy. And then we'll go ahead and include each of our solutions. All right, so we've built up our strings here. And I'm going to go ahead and import the timeIt library. And then we'll go ahead and set up our first test. So we'll go timeIt.repeat, which is the test I like to do. And then we'll pass our setup string, which is setup, and then we'll pass our first test in. So the statement we want to test is brute, and then we're going to repeat pretty random amount of times, but I like to pick 10, and then we'll just see how long the brute force solution takes. Okay, and then we'll modify this to use the comprehension solution, and then let's keep going. So the next one will be sliced. That one's quick. And then we'll use the constructor. And then copied, another quick solution. And then the generic copy function, so I'll call this one was called copy pack. Yeah, not surprising, the generic function's pretty slow. And then multiplication. I was hoping it would autocomplete there. And now that one was surprisingly fast. So it's hard to get this all in one frame, so I'll go ahead and post these in the article. But sort of to summarize, your quickest solutions here are sliced, copied, and multiplication, surprisingly. And then some of your slowest solutions are, well, the generic copy function, and then the brute force write your own loop, which makes sense. And then some of these solutions that sit sort of in the middle, the comprehension is slightly faster than brute force, and the constructor solution is pretty fast as well. But if you're looking for speed, use a slice, use the built-in copy, which is the one I said in the article's preferred, or you can use multiplication, which is ugly but is clearly pretty fast. And I guess that's it for performance. As always, take this with a grain of salt. I'm doing this on my PC. Sometimes I do these tests on my laptop. So, all right, so it looks like you've made it all the way to the end of this video. And as promised, I am going to give you a challenge. So at this point, we've covered nothing but shallow copies. So what I want you to do is extend this just one step further and write a deep copy for me. But I don't mean a true deep copy. What I mean is, if I provide a list for you that is nested like this, so we have this outer list and we have each of these inner lists, can you copy this? Meaning, can you write some code to duplicate each inner list and then place it in a duplicated outer list? And to prove that your solution works, you might want to do something like this, where you check that your primary list is not the list that you've copied, and that the inner lists, so maybe the list at 0 and the list at 0 in both lists, are not the same. If you can do that, then you will have written an algorithm that can solve this problem. Again, I'm not interested in a true deep copy. I'm only interested in a solution that can duplicate all of these. And if you're interested, I've actually started you off here in the comments with a solution. So if you want to see this live, I can actually write it for you. So what we'll do is I'll actually create a completely new list. We'll just call it nums, and it's going to store 1, 2, 3, and 4, 5, 6. And I'll duplicate this by calling it nums copy. And to duplicate this using a list comprehension, what we'll do is we'll say sublist for sublist in nums. And this isn't going to give us what we want, but I just want to show you. That looks like a copy, doesn't it? So we'll go ahead and say is nums, well, that's false. And the reason is we've actually created a copy the same way that we did what in our second solution, the one following brute force. But what you'll notice is if I do these at 0, they're still the same, meaning I can actually modify, and I'll show you that as well. I can actually modify the very first item here, set it to 2, and now nums is corrupt as well as nums copy. So let's go ahead and fix that. So nums should be fixed, nums copy should be fixed as well. And let's go ahead and change our list comprehension. So we have sublist here. Well, we need to break sublist down into items. So I'll say item for item in sublist. And so we'll have this expression on the right, which is going to iterate through each sublist. And then this expression on the left, which is going to iterate through each item in sublist. And now nums will look like this, and we can do our same test, which is false. But now we can add in this, and that should also be false. So that's my solution. I'd be interested to see what your solutions are to this problem. There are a lot of ways to solve this. My only rule is do not just use deep copy straight up, since I already showed you that solution in this article. All right, well, that's all I've got. If you like this video, go ahead, throw it a like, comment, subscribe. Make sure you complete the challenge. And you're welcome to put that comment either below this video or in my article. It doesn't really matter. I'm just interested in seeing some of your solutions to this problem. And if you like this challenge, I'll go ahead and throw them in new videos going forward. I'm actually planning to do that now, but I thought it would be kind of fun. Otherwise, special thanks to all my patrons. I like to list them here. If you'd like to be added to the list, go ahead over to patreon.com/therenegadecoder. That link will be in the description. And again, special thanks to ncold36 who keeps providing me with this wonderful art. I have also linked them in the description. If there's anything you'd like to see in the future, just go ahead. Don't hesitate to drop that in the comments as well. I'm looking to grow the channel. I think this will be my 6th video, and I'm trying to pump them out now. I have a little bit of free time in my semester. Pretty soon I'm going to be swamped again. So otherwise, have a good one.